All right, so the last case was the nothing weird happened case. The complementary solution and the particular solution don't have any repeats, and so we don't have any of that where we have to think creatively about what type of format we want the particular solution in. So this method, this case, is when we do have something complementary that kind of shows up. So let's look at what that is, and then we can talk about what to do about that. So let's start with our auxiliary equation, which should look familiar to us. That's that special case situation we talked about a couple of lessons ago. So that was where I want to take y, well, let's do m's. Yeah, why not? We'll keep it like that. So y plus the square root of something, y, right? So the coefficient is 1, so what has to go there? Square root of 1 squared. So what's our k? Our k is 1. And because it looks in that general format of m squared plus 1 equals 0, that means we're going to get imaginary solutions. And so our complementary format is c1 cosine x plus c2 sine x. Okay, so now what do we do? Okay, so let's go back to our particular one, so the one on the right side, so the 4x plus 10 sine x. And what would the general format of that should look like? Ax plus b. And then with the sine function, it should be c cosine x plus e sine x. But as you can see, that cosine sine also shows up in the complementary, so if we use it as is, that's going to give us an issue. Okay, and so this is where, if you read the rule called the multiplication case, if we have any duplicate terms, we simply take the duplicate terms in the particular solution, multiply by x, and then we're pretty much good there. So instead of using this one, so we're not going to use that one, we're going to use this general format. So ax plus b plus cx cosine x plus e x sine x. And then that's the one that we're going to go through and do the mechanics of, take the derivative and evaluate that. Okay, so I'm going to speed up the differentiation piece because I don't think you guys need to watch me take a couple derivatives, but I'll put back up the result and then apply it into our equation on the left. Okay, so I've gone ahead and done the derivatives, and I went ahead and collected all like terms and kind of wrote the result down here. So feel free to pause and check my math and let me know if there's a mistake on it, which is bound to happen sometimes. All right, and then I want to remind everyone that the ax plus b minus 2c sine x plus 2e cosine x is equal to our 4x plus 10 sine x. All right, so what does that tell us? That tells us that, well, a has to be 4, b has to be 0, negative 2c has to be 10, so that means c is negative 5, and 2e has to be 0, so e is 0. All right, so let's put all that in so we can have a nice pretty answer. All right, so our general solution was y equals c1 cosine x plus c2 sine x plus 4x minus 5x cosine x. And then we can apply our initial conditions. So just as a reminder, in case it's been a while for you, so our initial conditions were y of pi equals 0, and y prime of pi equals 2. Alright, so if we let's start with the y, so we get 0 equals c1 cosine of pi plus c2 sine of pi plus 4 times pi minus 5 times pi times cosine of pi. Well, cosine of pi is -1, so I can replace all of those cosine pi's with -1, and sine of pi happens to be 0. Okay, so that says 0 equals negative c1 plus 4 pi plus 5 pi. So it says c1 itself has to be 9 pi. Okay. Okay, so then to apply the second initial condition, I kind of need to know what the derivative looks like. So that's y prime equals negative c1 sine x plus c2 cosine x plus 4 minus 5, and we'll do x times negative sine x, and then cosine x times 1. And then we'll put in the y prime of pi is equal to 2. So we'll put it 2. Oh, and actually we know c1 is 9 pi. So I can put that in there. Alright, so then I got 2 equals negative 9 pi sine of pi plus c2 cosine of pi plus 4 minus 5 times pi times negative sine of pi plus cosine of pi. Okay, and since sine of pi is 0, means that goes away and that term goes away. And what are we left with? We're left with 2 equals, cosine pi is -1. So -1 there. Alright, so we're left with negative c2 plus 4 minus 5 times the -1. So that's plus 5 pi. Sorry, doofus move. That's not a 5 pi, it's just 5. Okay. So that means that C2 has to be 7. Okay, so let's put that all together with our constants. So our solution is 9 pi cosine x plus 7 sine x plus 4x minus 5x cosine x.